So welcome to the latest 42 Crunch webinar. We've had a lot of folks asking us about the role our technology plays in the mobile realm. And so today we're delighted to host our partner Approov, a company that specializes in mobile app protection, onto the series. Our speakers will explain the challenges, particular to extending protection from the mobile application to the backend API, and then via a live demo showcase how the Approov and 42 Crunch platforms can work in tandem, delivering a shift left as well as shield right runtime enforcement, extending all the way to your mobile apps and the environments they run in. So today's speakers, Colin, hopefully you're familiar with. He heads up our developer advocacy initiatives. He's an API security researcher and also manages to edit the industry's leading weekly API security.io newsletter. And our other guest speaker today is David Stewart. Is CEO and co-founder of Approov, a company that ensures that only genuine mobile app instances can use enterprise APIs. So just quickly before we kick on, some housekeeping rules. You're all muted. If you could please submit questions via the Q&A box. We'll try and address the questions during and at the end of the presentation. And a recording will be shared, made available to you all on demand within 48 hours. And we're also going to push a number of polling questions to encourage your participation. Before we do that, I'm just going to ask Colin to walk through the agenda, and then we'll push the first polling question.
Certainly. So thank you very much, Hugh, and welcome to everybody joining today's session. So what we're going to do is we're going to look at a basics of mobile API attacks, API vulnerabilities, and then also ways that mobile APIs can be abused. David's going to take us give us a walkthrough of the Approov product device protection platform. I'm going to look at the 42 Crunch solution, particularly around what can be done around API protections. Then we've got a live demo, which would be really interesting. We've got actual live applications working. We're going to show the protection in place. We'll go through some of the use cases and benefits, and then Q&A. So quite an action-packed session. So the first question before we start is really to understand what things our audience is doing at the moment. How are they seeing their applications being threatened? So pick one. So only one there, please. The single biggest threat to your mobile applications. Which of those 5 domains are you having the most trouble with? So put that question up, and we'll wait until the answers come through.
Okay, I'm going to end the poll now and share the results.
Okay, so that's quite an even spread. David, user credentials, high on the list, and API backend vulnerabilities also pretty high on the list. How does that correlate with your experience and what you see?
Yeah, it's actually very interesting. What I think is interesting immediately about it is the API channel integrity is something that people don't worry about.
Yeah.
More than the things they do worry about. So that's quite interesting. So we'll get into that one in a moment. But yeah.
Yeah, absolutely. Yeah, I also think that the fact that the channel security didn't come up as a high one, I think when we showed the man in the middle attacks, that might change people's minds. So David, I'm going to hand over the presenter rights to you, and let's get you started on your slides, please.
Great. Well, thanks, Colin, and it's really good to be here. And the things that I wanted to talk about initially, I'm going to talk about the Approov platform, of course. But before I get there, I'd like to cover a couple of things which we find quite often gets misunderstood. So doing a bit of myth busting, if you like, and just making sure we have a clear understanding of what we're talking about when we're trying to protect these kinds of applications and communication channels. The first thing that people quite often get a little confused about is vulnerabilities and the role that they play in attacks against digital platforms. And they do play a role. And I'm not here to say that vulnerabilities are not important. Of course they are. And we're going to talk about that. Yeah. But the bad news is that vulnerabilities are not the only thing that you need to worry about. API abuse, which is a slightly different category, is also something that you need to think about. So vulnerabilities are, of course, well documented and are, if you like, a bug in the API, to think of it that way, where the API can be upset, can be made to do things that it wasn't intended to do. But the other side of the coin is the API abuse, and there's a famous quote from Gartner about how API abuse will become the #1 attack vector in 2022 that they made several years ago, and they actually concluded that they reached that point last year. So it has accelerated very quickly, and API abuse is effectively using the API in a way that wasn't intended. So if you've written an API to communicate between a backend and a mobile app, then anything that tries to use that API that's not a mobile app or not the mobile app that was intended, that is API abuse. And it has many forms, but the important thing to recognize here is that it doesn't rely or doesn't need to rely on a vulnerability in the API itself. It can simply be impersonating genuine traffic. And that can create all kinds of damage. And I'm not going to go into all these attack vectors here, but the point is that you do have to think about vulnerabilities as one thing you have to deal with APIs. And the second thing is the API is being abused by somebody attempting to access the services and the data at the back end through scripting methods primarily.
Sure. I know when we spoke yesterday, I gave you that kind of anecdote from my own experience. I think back in 2020 when the COVID pandemic started, and certainly in the UK, and I think it was a global phenomenon, supermarkets ran out of stock. There was shortages of toilet paper and people couldn't get booking delivery slots on supermarkets. So I actually took my mobile app that my supermarket provides, threw that up through a reverse proxy and kind of scraped the API for polling booking slots, and then was able to then automate and go and look for empty booking slots. And I think the supermarkets all became pretty wise to that, and then took their mobile apps off the market. So while not a vulnerability in the app itself, certainly not in the API, I definitely started using that API in a way that they really hadn't anticipated. So I think that's the kind of thing we're looking at. And I think there's lots of examples where people are doing unintended things to APIs.
Right, well, unintended by the developers of the API. But the people doing them are certainly very intentional in their behavior. And I think that's a really interesting example, because quite often when you talk to people, they say, well, there's no interesting data on our APIs. Nobody would be interested in abusing it. And there's an example where probably nobody would have imagined, there would ever be a need to scrape the availability for supermarket deliveries. But all of a sudden, we're in a pandemic and there is. So the point is that even though you may think that your data is not of interest to anyone, if there's a way to create trouble, make money, game the system, then somebody's going to do it because it's easy to do. So these things definitely have to be thought about. And another way of saying what we've just been talking about is the whole shift left and shield right argument. So shift left is, of course, the idea of building in secure by design, getting it early on in the design cycle and making sure that things are, the APIs are clean when they come out, which is obviously an excellent thing to do. But the other thing is you do also have to shield right when you're in production, when you've deployed. You do have to build a shield around your API and your mobile app in order to make sure that people aren't able to abuse it in the kinds of ways that we've been talking about. So I think that's the first thing I wanted to cover. The second thing is mobile itself, because for many people, their idea is that all API traffic is born equal, and that's not true. And depending on where it's coming from, it may be more susceptible to abuse than other places. And if you think about it simplistically, APIs communicate between two servers, between a web page or web app and a server, or between a mobile app and a server, then those are the increasing levels of difficulty when it comes to security. So server to server is relatively easy. web to server is a bit more difficult, but not as dangerous, and mobile is the worst case. And I'm going to talk about why that is. Now, generally speaking, people think about it in terms of, well, I just need to authenticate the user to make sure the user I know which user's logged into the app. Then I've got an API key in the app. The API request comes in with the user credentials and the API key, and it comes over a TLS connection, and then we're all good. And unfortunately, the picture is a lot more complicated than that. And the reason is that when you think about mobile apps, they really are a special case. I mean, you're taking mobile apps are complicated pieces of software with lots of interesting, not just credentials, but business logic built into the app. You want to create a great user experience for the customers, and therefore a lot of intelligence and processing is built into the app so that you can do things locally and not necessarily communicate everything back to the servers that provide the data. So as a result, there's actually quite a lot of interesting stuff in the apps that bad guys can use. And not only that, you make it available to anybody to download without having to say who they are, and they can run it on any piece of hardware they like. They can do that for as long as possible, study it, reverse engineer it, and do what they want. And that's why we consider it to be a real treasure trove of information for hackers. Now, the important thing again is that reverse engineering the app might be something that they're going to do, but in fact, in many cases, all they're doing is studying the API. And they use the app to do that. So by using the app and looking at the API traffic, they can work out the correlation between the things users do on the app and the API requests that are made and the data that comes back. And from that, they can then build scripts. They understand the credentials that are needed. They understand keys that are needed. They understand the instructions, and therefore they're able to relatively easily build scripts that can impersonate the mobile traffic. So it really is a difficult problem to solve because of the deployment mechanism of mobile apps, and because you don't know how your mobile apps are being manipulated. So the other thing that's interesting about mobile apps is actually the app quite often creates a bottleneck in extracting data from the backend. Again, this is something that if you're a mobile app, if you have a mobile app in your business, you probably never thought about. But quite often when the app is communicating with the backend, it's naturally controlling the amount of data that's requested, and therefore the amount of data that you get. So it might be that the app is only capable of asking for one piece of data. But as soon as you connect a script to it, then that script can ask for more than one piece of data at once. So suddenly you may find that that a script is able to extract large amounts of data from your backend systems without you realizing that was even possible. And here I'm not talking about doing high frequency API requests. I'm talking about doing API requests that request more data than the app would necessarily request. And so it's once you remove the app from the equation, you bypass it, and you've got a script connecting to the API. Sometimes you can create situations where lots of data becomes available quite easily. So when we think about when you think about the mobile, protecting a mobile business, we think about 5 different channels, not just the user credentials and the backend entry point. We think about the app integrity. So how do you know that the app is present when the API request is made, and that the app has not been modified? How do you know that the device that the app is running on is not being manipulated or been modified in any way? And how do you know the channel between the app and the backend is not compromised, is not being, the data or the traffic is not being read or indeed modified? And the answer to these questions is it's very hard to know. So you can't trust anything between the user and the backend service. And that's how we think about it. So I'm just going to show you at a very high level what Approov does, and then we could pass it over to Colin, who's going to show you everything working in action. But just to give you the basic idea of how we protect the app integrity, the device integrity, and the channel integrity. The Approov system, just what you're looking at here is a mobile app that's communicating with its own API down the page to the server at the back end. So this is your business. So your business is the mobile app, the API down the page, and the server. On the right-hand side is the Approov cloud service, and I'll talk about that in a moment. So the two pieces that we provide are an SDK that you basically drop into the app, and a cloud service that communicates directly with the SDK and manages the authentication process that we're going to use to prove the app integrity. And the important things about our approach are that number one, we don't add or include any secrets or credentials in the SDK that could be used against it. And secondly, the SDK doesn't make any decisions, because if the SDK decided whether the app was good on the mobile device, then that would be a severe point of weakness from a security point of view, and that's exactly what the bad guys would target. So the SDK does some intelligent things, but it doesn't make any decisions. So what happens is that you create your app, and then before you load it up into the App Store, you register the app with the Approov cloud service. And again, at a very high level, you can think about what we're doing here as like a DNA test of the app. So we extract the DNA sample, if you like, from the app before it goes into the App Store, and that gets stored in the Approov cloud. When the app launches on one of your customer devices, it communicates with the Approov cloud service and requests to be authenticated. A random challenge comes back, and then a series of deep integrity measurements are made of the app and its environment. And they're complicated, they're dynamic, and there's several of them. And basically all of that information gets hashed back and sent back to the Approov cloud service in a very short period of time, such that your customers won't even notice this is happening. The Approov cloud service, of course, knows what the right answer is. So it can immediately decide whether this is coming from a genuine app instance or not. If it is, it provides a very short lifetime token back to the SDK, and the SDK places that into the API request that goes down the page to your backend. So basically what happens is your backend receives an Approov token. It's a standard JOT token, and it is able to determine whether that token is valid or not. And the simplicity is that you add the SDK, and it automatically handles all of this communication. As an app developer, you don't have to do any of this stuff. The SDK handles all the tokens and places them into the API request headers automatically. So you can you don't have to worry about any of that stuff. It's very easy to do. And because it's a standard JOT token, then the token checking at the back end, as I'm sure Colin will show us, is relatively straightforward too. So the orange key that you see here is the secret that the tokens are signed with. They're signed with if they are valid, and this is important to notice, that the key is only known to the API endpoint and to the Approov cloud service. The app itself doesn't know what the key is, therefore it doesn't know whether it gets a good token or not. And incidentally, if the authentication fails, we send a token anyway, so the app always gets a token. It just doesn't know whether it's a good one or not. And finally, this whole process repeats every 5 minutes. So we're also able to detect changes in the environment during an app session. So it's not just a once-in-time check. It happens every 5 minutes, as I said. So big picture, there's a lot of detail below that, which we can get into if you've got specific questions, but I just want to give you an idea of what you're going to be looking at when we get to the demo. I mentioned that we also look at the device integrity. We look at the environment that the app is running in, and we detect a whole range of things. This is actually just a subset of the things that we detect. And you can consider this a security policy that you can set. So you may decide that none of these things are desirable. So you would have the default security policy, which is that we block all of them. But there are particular verticals, and there are particular geographies where, for example, some of these things might not be a definitive sign of a bad guy. So, for example, a rooted phone. In the old days, a rooted phone was considered to be the sign of a bad guy. These days, the positions are much more subtle. So there are reasons that people root their phone, for example, to install performance mods for gaming, but it doesn't make you a hacker. So for a number of our customers, they do actually allow rooted phones, but they don't allow any of the other things, which would be other clues that a hacking exploit is underway. So you can consider this as a menu of stuff that you can use to define a security policy, and you can set a security policy for your business, and then you can change it anytime you feel like it, and it will instantly change in any of your installed apps. Channel integrity. Well, we're going to talk about man in the middle a bit later on, but one of the ways in which you combat man in the middle is having certificate pinning applied to your APIs. And we quite often find, I mean, most people will say, yes, we understand that we should be pinning our APIs, but that doesn't mean they do it. And one of the reasons they do it is because they don't do it, rather, is because they are concerned about not implementing it correctly, or implementing it correctly, but then having to store certificates in the app. And then if the certificates become compromised or need to be rotated, that means they have to issue a new app. And that creates quite a long delay while they wait for their customers to upgrade their mobile devices. So Approov comes with included in the Approov package, actually, the service is dynamic, what we call dynamic certificate pinning, which is an end-to-end certificate pinning implementation. But more importantly, the certificates can be updated directly into the apps via the Approov cloud service. What that means is that if you need to update your certificates for any reason, you can do that instantly to all of your apps that are installed in the field. You don't have to require your users to upgrade their apps, which is a huge saving. And we've got several customer examples where that has really saved them a lot of heartache and money with that feature. And finally, you want to know what's going on within your install base. So there's a whole dashboard. And I think Colin's going to show us some of that during the demo. I'm really looking forward to this demo, actually, because I haven't seen it yet. But Colin tells me it's great, and I'm sure he's right. But anyway, this also allows you to see what kind of attacks are being repelled. So you can see what kind of rejections you have within the platform. This is all live data. You can also see past data, so you can get information about your iOS versus Android demographics, which versions people are using, all kinds of stuff like that. So there's lots of interesting information here that can show you what's going on within your customer base, but also allow you to perhaps tune your security policy as well based on what you see, what kind of threats you see. So I think that was it from me at the moment. Oh no, I had 2 case studies that I added. Sorry, I forgot about them. Just very quickly. So one in healthcare. This is actually a pandemic related story. This is a clinician app. MV is a healthcare IT services company in Brazil. And they had a clinician app which was only used inside hospital networks. And during the pandemic, of course, suddenly they had to offer services. So people were not able to come into the hospital. So the doctors were having to access patient data via external networks. And they had it pen tested. We may talk about pen testing later on. It's a good story about pen testing in this particular one, but we might come back to that. But basically, the pen testers identified that there were immediate problems with opening up the APIs to be accessed by devices outside of the hospital network, because there was no way for them to be able to verify that it was really the mobile app itself. So Approov was quickly added to their security layers and saved them a lot of potential danger in terms of data leakage. Second one is Sixt. I'm sure many of you have heard of Sixt. So they're a mobility services provider, car rental, car sharing, and other services. But really, they're like a retail company. We do have quite a lot of retail customers, and basically their situation was that the data they're providing on their APIs that was supposed to be just transmitting between their servers and their mobile apps was being scraped by third parties, and they were basically taking that data and reusing it, either using it for, they might have been using it for competitive purposes in order to, set their own pricing at slightly below. That wasn't the case with Sixt. With Sixt, it was really aggregators who were taking the data from multiple sources and then providing a holistic picture of all the offers, a bit like a kind of comparison site, but in a mobile app. But the problem was that the API access also allowed you to open vehicles. So there was a lot of potential risk as well. So they needed a solution that was, they weren't actually against sharing data via APIs to third parties, but they needed to control who they were sharing it with. They needed to control what data was being shared and be able to identify their own mobile apps, the requests from their own mobile apps versus requests from other third parties. So that's basically what they use Approov from. Again, there's the whole load of case studies like these two on our website. Feel free to go and have a look around and see if there's maybe some other ones that are more appropriate to your business, whatever it is. And I think I'm right that I'm finished now. So thanks.
Perfect.
Over to you, Colin.
Yeah, thanks very much, David. And just to remind folk, we had one question come in, which saw the person asked the question, found the answer on your website. We can come back to it in a moment, but also just to remind people to get the questions in. So long, we do have a giveaway for the person who asks the best question during the session. So going to move through my presentation quickly because the exciting bit is the demo. And a lot of this will become clearer when you come to see that in action. So why is API security hard? We've got vulnerabilities. We've got the fact that APIs behave differently to the way web applications behave, the way they're written. But mostly we've got disadvantages because people can automate APIs, right? They're easy to attack. APIs generally are quite easily discoverable using tools like KiteRunner. I'll show how easy it is to just go and discover an API but by sniffing the traffic. They're well documented. The APIs tell you how to attack them, right? They tell you the parameters. They tell you the methods to use. And the attacks can be automated, and there's great tools to do this automation. The problem is also that the tools that you're using at the moment to protect your APIs probably don't work terribly well. There's a blog post that I've written on how traditional tools don't pick up API vulnerabilities. That's worth reading. More detail on that topic. Second polling question now. How are you currently protecting your APIs? Now, I'm specifically talking about runtime protections. So are you reliant on web application firewalls? Are you using an API gateway product or something like Apigee? Are you using a dedicated API micro firewall? And that's obviously one of the things we're going to cover in much more detail in the session. Or are you using some kind of runtime protection? So some kind of agent monitoring service like RASP or an IAST solution. So people could pop those answers up, get voting on that, and also just to remember to get the questions in as well.
Okay, I'm going to end the poll there, and I will share the results.
Okay, so that's not entirely surprising. So overwhelming majority either in the WAF or API gateway camp. That's to be expected. API micro firewalls, only 4%. Well, you're going to enjoy the rest of this demo session then, because we're really going to show you the power of what we can do. And RASP, has a valuable place to play in runtime protections. So thanks for the participation. Whenever we talk about API security, I'm always mindful that I don't want to get people pessimistic about this. API security, I'm optimistic about this space. I think that, it's an opportunity by leveraging the power of the open API specification to actually really get security right. We're all about at 42Crunch, we're all about the positive security model. The fact that, we are going to have very low false positive, false negative rates. Positive security model, you specify the input, you precisely define the type of data that you want in your request and response, and then anything that is not matching that gets rejected. And we'll look at a demo where I show that working. So open API specification, use the open API spec to drive your entire development process. Be able to, so we talk about our products, we've got a security audit product. If you're doing API development, you're probably familiar with the VS Code extension that we have. And we also have a conformance scanner that's able to fully validate your backend implementation right through your development process. So the benefits of this positive security model, the block list, which is the approach that a WAF would take, attempts to interpret that data and decide whether it should be allowing that data through. So it attempts to block known bad. And therein lies the problem. What is known bad? How known is the bad? And that's the problem. So it tends to be both false positive and false negative. Now, the benefit of the positive security model is you explicitly define your conformance. So exactly, what you want in and what you want out. So it only allows known good. The challenge obviously is that you have to get that specification 100% correct. Without that, you're going to have deficiencies. So building the guardrails, how do you go about improving the security posture of the APIs? Provide your developers a solution, provide guardrails, provide guidance on how best to implement APIs, define the policies, put a governance process in place, but enable those developers to be creative and develop solutions. So 42Crunch's approach to security, David had already alluded to the mantra of the shift left and shield right. So shift left, we're driving developer security via the open API specification. We help people design and develop their APIs as far left as possible. And then we're able to use that open API specification to drive that development progress through the development lifecycle. Shielding right, and that's the focus of the demonstration today. We're going to be looking about how we have this very low footprint micro firewall or policy enforcement point that we can put right in front of your API. And that's what the shield right approach is. So just summarizing, we've got the three products: the API audit, the API scan, and API protect. So talking about the protections that we provide. So within the open API specifications, we've got an example there. We have an API login page, and what we've done is we've got a number of specification extensions, the X- extensions. So we provided our own there. The example we're looking at there is rate limiting on an API. So what we can do is we can specify a window, a maximum number of hits allowed in a window, and we can implement a policy in the micro firewall right in front of your API. And we can do that on a very specific and localized. So that example there is applying to API/login and only on a post request. So it can be very highly granular. Security headers is another thing that we can enforce in the firewall. So there we're ensuring that we've got the appropriate security headers. And then JOT validation. So David had already spoken about the fact that the unit of data exchange between the Approov SDK on the mobile device and the backend is a JOT token. It's a standard JOT token. And then what we do in that backend is in the backend code in your API, you can go and manually validate that, but you can use our micro firewall sat in front of your API backend to do that validation for you. Right, and that's really the crux of the demo that we're going to show. Now, the advantage of doing this in a firewall solution or outside of the code is you really separate that division, the responsibilities. So your developers don't have to be aware of your security mechanism in place. right? The firewall can do that validation for you. The other thing that you can do is you can roll that firewall out across your organization. So rather than having to go and update 30 backend API applications, you can just do a rolling update to that firewall. But that's not all that you can do with it. You'll see the power of this in a moment. So coming to the live demo, so I'm going to go off camera while I do this to avoid you staring at the back of my head while I'm doing the demo. Right, we're now going to have a look at a live demonstration of the 42 Crunch security platform working in conjunction with the Approov mobile protection platform. So we'll look at the agenda for this demonstration. So we're going to start off by taking a quick look at a typical mobile application and the basics of how you can abuse that application. So a really basic intro to this, how to connect up a proxy, how to get it working through a proxy, and what you can do by kind of eavesdropping on that network traffic. Then we're going to show how Approov can help you defending your application. So firstly, how Approov can prevent those man-in-the-middle attacks, and how it can also detect if you have a debugger attached. And then we'll have a look at the Approov backend protection working in conjunction with 42 Crunch. And really, this is going to be showing you how the JWT token validation works. So that's with expired tokens or without a token. And then we're going to take a look at additional protections that you can instantiate with 42 Crunch, particularly around data constructs, so excessive data exposure, and then broken function level authentication. Before we dive into the demo, let's have a look at the environments. We've got the same application, and I've built two different versions of it. So the first is what I'm calling the red demo. Red demo environment, red unsecure, right? This is the one with no protection. So we've got an Android mobile app. We're connecting through to a backend using the OK HTTP client. We're terminating the SSL connection with a traffic reverse proxy that is doing the Let's Encrypt certificate serving for us. And that then connects on through to a Node.js API backend. So that's the unsecured application. And then we have a version I'm going to show you now, a second, where we route that traffic through the Charles web debugging proxy and then show how easy it is. It's almost trivial to intercept traffic on that. Right, so let's get the environment set up. So let's just get Charles up and running for us here quickly. Charles is a web debug proxy. I've got that running locally on this machine. And what I'll do now, I'm just going to show you the proxy setup. So let's clear that out. And Charles is really simple to set up. So proxy settings, I've got Charles running on the local host. I've got it running on port 8888. Right, and you can see already it's sitting capturing traffic. I've got the SSL proxying enabled. If you haven't used a proxy to capture mobile traffic, it's really simple. The basic step is you install the Charles proxy on your device. I've already done this on the mobile phone that I've got connected. Really easy to do. One step, click and install the certificate, and there's the mobile device screen. So let's watch the application now. So we're going to run the red version of that app. And what I need to do first, before I do this, I'm just going to show you the application working. It's got two endpoints, a hello endpoint and then a shape. You can see I'm getting some shapes. And what we can see now is that's not being captured in Charles proxy. Now, the reason for that is obviously I haven't set up the phone at this point. So we'll go through and I'll show you how simple it is to do to just modify that network. You do advanced options, you set a manual proxy, set the IP address of the host adapter on the machine that I'm using. It's 168.16.12. Right, and I set it to port 888. Right, so that's now working. What I'll do now is I'm going to do say hello again and keep an eye on the Charles proxy window. Right, you can see that changes significantly. So I'll do 3 of those. Let's go and get 3 shapes. Let's get a circle, a triangle, and another circle. Right, so that's easy. Now we're going to have a look at what Charles was able to intercept. So it's seen 3 hello messages. It's seen 3 shapes messages. It got a circle, got a triangle, and it got another circle. Right. If we go have a look at the content, let's have a look what we're seeing here. So we're seeing a service certificate. Let's expand that out. Just have a look on that. So we've seen that we've got a service certificate that's being served up by the traffic reverse proxy. That's allowing the SSL termination. Now, this is a fully SSL connection. As far as the application is concerned, everything is secure, but obviously the application is not defending adequately against a man-in-the-middle attack. And let's just show you this in action. So if I go over onto the console, having a look here, we've basically, that's the debug output from the Node.js backend. You can see I've got 3 requests to get the hello. I've got the 3 shapes. I've got circle, triangle, and circle that came through. The top windows there is just a Docker container debug logs. So now the danger of allowing your users and attackers to be able to easily sniff and eavesdrop on your API is the fact that it's very easy for them to attack and abuse your API by doing things like this. So I'm just going to remove that verify no. And the endpoint is called hello. Now, that's expected. I'll show you what that looks like in Charles. So Charles has come back and said SSL handshake failed. Simple reason for this, the HTTP I'm using here, I haven't installed the Charles certificate in its chain. I kind of do that deliberately so I can demo the response that we get. All I have to do to that is go and put a verify equals no. That just simply says to HTTP, just look, you're going to get an error, just ignore it. And there we go. So we've got a hello world on that. Let's go look at the V1 version of that. It's a bit richer. So there we've got a JSON response object on that V1 hello. You can see the data coming back. We can do the same thing with the shapes. Right now, that's the expected result. We're missing an API key. So what we've got to do, let's just go and get the shapes. We'll put the API key in. We'll fire that back up. And there you can see we've gone authenticated with the API key. And you can see on the back end here, we also seeing that we see that key. Right, so super simple to be able to sniff that that data off the application as well. We can actually grab that key in the traffic as well. Right there, we can see the API key is actually obviously coming across the transport. If we've hooked it at SSL level, it's very easy to go and sniff that API key, and we can lead to leakage. Right, so we've actually got a couple of issues here. We're going to show you another one now. While we digging around on this API, we notice that, and we can do, there's a number of ways we can do this. We discover there's another endpoint called info. Now, what's happened here is our developers, while they were building and debugging this application, they've gone and exposed an additional endpoint, which they were using for development purposes. That just dumps out some useful information, things like the host name and whether the approve is enforced. But unfortunately, it's leaking some confidential information as well. Right now, this is reasonably not an uncommon scenario with data leakage. Unused endpoints, unintended endpoints that have been exposed. We just found one, I guess, that endpoint name. You can use tools like KiteRunner to automate that process. Right, and quite a serious issue with this API. We come back to this in a moment. So now we've had a look at being able to sniff. Now what I'm going to do is I'm going to exit that application and I'm going to turn the proxying feature off. Just bear with me a second while I remove that. So the proxy is now disabled. I'm going to stop the capture on this, and what I'm going to do now is I'm going to load up the green version of the application, which is the same application, except this time it is secured with Charles, and I'm going to. Right, so now I've switched hosts. The secure version is hosted on the 42C.2. We can see some logs coming up on the Docker window. There's Approov, the 42 Crunch firewall is running. That's the logging. And this is going to be the backend application view when I start hitting it. So what I'm going to do is I'm going to send a hello request. Right, let's go. You can see that coming through on the bottom window. We'll go to the application. There's the hello request. Now I'm going to go and get a shape. Right, I've got a circle, get another shape, another circle, and a square. Right, you notice that little delay on the first one. And what was happening there was the application was validating and then talking to the Approov backend and getting a token. Right, so that's the round trip. We can see those coming through on the back end. Now, what we'll see differently here is for each of the shapes requests, we are getting an Approov token coming through. We're getting another Approov token coming through and another one here. Now let's look how that token validation is working. So let's have a look at that green demo environment. Right now, the green demo environment exactly the same as the previous one, but we've added components both on the left and on the right-hand side. On the left-hand side, we've included the Approov SDK. Now, the mechanism of doing this, it's a Maven dependency to pull in the SDK library. And I think in this application, there's probably 6 or 7 lines of code change. And that really is to use the OK HTTP client that is included with the SDK rather than the standard default version. And what I've done here for purposes of illustration is I've used the hello endpoint uses the standard OK HTTP, in other words, the unsecured version, whereas the shapes one uses the version that comes with the Approov SDK. Going through public cloud, we're hitting the same traffic reverse proxy termination to get the SSL. And in between that, we've got the 42 crunch firewall. Now, the 42 crunch firewall, again, acts as a reverse proxy, listens on an incoming port, translates that traffic through a firewall function, and then hits the back end. And what that firewall is doing is it's being controlled by the 42 crunch platform. We have a look at that in a second. And that is enforcing a rule set down onto that firewall based on an OAS definition. Okay, so that's what the environment looks like. Okay, so what I'm going to do now is I'm going to use the command line to be able to go and get a shape. And you can see I've gone and hit that. I've supplied the API again. I've got the circle and shape. Coming back, let's just get the log running again, get a bit of white space. We'll repeat that step. All right, so we can verify that it's behaving in the same way. Let's go and find that info endpoint. We'll see we still got an issue with the info endpoint. So the green application working very much in the same way now. Okay, so now that we've seen that the green application is behaving much in the same way, let's go and have a look at what this looks like in Charles now. So I'm going to do a hello request. And we can see we've been able to intercept the hello request. Now, this is not entirely surprising because that's not secured. That's not using the Approov SDK. We can see we're hitting 42C2. We're able to intercept the call. That behavior is expected. However, let me try and make a call to get shape, and we have a look at the difference in behavior. So what's happening here is that we're getting a message on the device, but we can see that we're not hitting the proxy. So we didn't get the shapes request coming through. Now, what's happening under the hood there is that the Approov SDK is trying to connect to the 42C.2 application server. But what it's detecting is that the certificate has changed, right? Effectively, the host's identity has changed, and it's rejecting that call as a man-in-the-middle attack. That's why Charles doesn't report that, because it aborts the SSL connection before that happens. So, you know, that behavior is exactly as expected. We'll try and go and we'll just see if that's repeatable. All right, same error, we'll do another hello, and we can see that that comes through. So what have we shown here? We've shown that using the Approov SDK, we can prevent man in the middle. We've effectively defeated the Charles proxy. That's useless to us now. So we're not going to need this anymore. So I'm going to quit Charles. And what I'm going to do is just quickly remove the proxy on the device. And then we'll have a look at another attack vector. Right, so we've got direct connection on the device. Let's just verify the app now is working as expected. Right, good. We're getting shapes. We can see that we're getting the tokens coming through and everything is working just fine. Another thing that Approov can do for you, another example of the protections that it can offer, is it can do debugger detection. So another way to attack mobile apps is to use an Android debugger. So what I've got here is I've got a session established with the device, and I'm going to launch that same application in debug mode. Right, so we start up the debugger. We'll get the UI back and up and running. And we're going to try and do things with the UI again. So we're going to say hello. Again, that works because we're not protected with the SDK. However, let's go and get a shape and see what happens here. Right, we see we get a 403 error code. Okay, that seems unusual. We haven't seen that before. Let's see if that's repeatable. Definitely another one. And in fact, a third one. Right, so there's something going on here now. If we just remember our topology and environment, we've got 42 crunch sat in the middle here. So let's go and see what 42 crunch is seeing on that network traffic. So let's just go and refresh those tokens, and we can see we've got 3 403s being reported by the 42 crunch platform on that V1 shapes endpoint. Right, so what it looks like is that 42 crunch is not happy with that token that it's been given. And in fact, it's getting an invalid signature. We can go and pop that up and expand and have a look what that JOT validation is doing. We'll look at how that is defined in the Open API specification. But basically, we're failing a message integrity check, right? And that is because Approov has failed to give us a valid token. Approov, we go and look on that live metrics. We'll refresh that. Approov here is seeing that we have something in the way and it's erroring that one out. And then the JOT validation isn't working. I'm going to grab that token. It comes through on the wire here. 42 crunch can see that. We can also see, if we wanted to see it, we'd see it there. It's that same token. And what I'm going to do is I'm going to have a look what Approov thinks is going wrong with that. So I'm going to do token check, and I'll paste that token in. Right. We can have a look there. Approov is essentially in the claims that it's returning. It returns an error code, and that's telling us that it's detected a debugger. Okay, so we can see that we're failing again if a debugger is attached, and the application is refusing to behave as expected. So what I'll do is I'll stop that debug session, and what we'll do now, we're going to go and have a look at the what that definition, how we define that endpoint. So if I load up the Open API specification that is in force there, and I go and look for the V2 shapes endpoint, right, what I can see is I've got a local protection strategy. This is the extension language the extension mechanism, the decorator that we add to the firewall. We're doing HMAC validation. We're looking in the Approov-token header, and we're validating according to these two local definitions. Let's go and have a look at those definitions. The first one is the header. We're looking for JWT, and we're looking for HS256 signature. The data we're validating against is an IP address, and then some error codes and identifiers. And that is exactly the same as it being returned on that line. Right, there's the claim. You can see it in the curly brackets. All right, so that's what the 42 crunch platform is using to validate that claim. We can see if we decode that, we're getting a debug. Okay, so now what we're going to do is we can show this working again. What I can do is if I go back to this window and I try and do a claim, let's try and do something with, I'm sure I'm going to have an expired token here. If I don't get one, I will paste one in a second. Right. Right, we're getting, again, I've just copied whatever I happen to have on the clipboard and pasted that in. Again, we're getting a 403 forbidden. right? We go back to the 42 Crunch platform and have a look what it thinks is going on here. And we're going to see another one pop up, token has expired, right? So that's now validating that the token has in fact expired, right? And that again is being rejected by 42 Crunch. What I'll do for illustration, I'm just going to flush out that window, right? And I'm going to hit that command again. Now, what you'll see is the backend, the Node.js application on the backend never sees that request, right? Because that request is actually taken out by 42 Crunch. We'll just reload that window, right? We get another token has expired. So what we're doing is we're not even hitting the backend. 42 Crunch isn't allowing that request through, it's dropping it. Okay, now let's try and give it a request. We'll take the token out and we see again, we get a 42 Crunch error coming back. We didn't hit the backend. And let's go and have a look what that message is. Now we should see something different indeed. Right, JWT header not found. Right, so we can see how we, using the platform, we can enforce all of those JWT validations. The final thing we're going to look at is we noticed that we had that info endpoint that was leaking a bit of information. And let's see if there's anything we can do to suppress that. So it's not at that endpoint, it's in fact there. Right, we're still leaking that secret API key. And if we go back to the code, and I'm just going to get this up and running. What I'm going to do now is I'm just going to take a copy of that file and we call this version 1. Okay, and now let's have a look at where the info endpoint has defined. Well, actually, let's have a look at where that secret is coming from. So we can see in the schema definition, let's go and find it for you. Right, here's where we define the info response. So that's the response schema for the info record. And we notice we've allowed this Approov secret value in. So what we'll do here is we're going to get rid of this. So right, let's remove that there. We definitely don't require it. Let's go and find other instances of that. Right, so we totally removed that secret from the specification. And now what we do is we flip over to the security platform. And what we're going to do here, we're just going to update that definition. All right, so what I'm going to do is I'm going to upload a new spec to the platform. It's exactly the same as the previous one. But what we've done is we've just removed that secret field from that data response. Right, so we'll crush that. We'll go and reconfigure the firewall. Now what's happening is this is just pushing the new firewall configuration down to the running instance. Okay, that's taken effect. And now we're going to try and repeat that. Right, we can see now, instead of getting a response back, we're getting a 502 bad gateway response validation. Right, that sounds promising. We're going to go to the platform. We're going to look at those transaction logs. And we're going to see validation of additional properties, right? And there really is the key. So response validation failed. So what's happened is the backend has returned something called Approov secret. The firewall has had a look and said, well, I don't recognize that. It's not in my specification. And what it's done is it's effectively dropped that field. Okay, we'll do that again. Let's just flush that. We're going to redo the request. Obviously, we're hitting the backend. Backend is responding, and then the firewall is blocking that. Now, that's all good and well, but we decide, you know what, having this info endpoint there is just really not a good idea at all. We'd actually like to completely get rid of that. So let's do another version of this. So we've shown how we can address, almost trivially, how we can address the OWASP API security top 10 issue of excessive information exposure. that's easily done, right? We can suppress that record. But when we look at that code, we realize, that endpoint is actually not taking any form of authentication. And we've actually got an instance of broken function level authentication. So let's do something better here. Let's go and remove that endpoint entirely. Right, just not very graceful, but effective. I go and delete that endpoint completely. Let's save that out. Let's exit, and we're going to go through the same sequence here where we are going to update that definition. And we now get the version 2. All right, so we're going to try and address this by removing that function. We will reapply the configuration to the firewall. Let's just rerun that. So that's running. We're going to come back here. We're going to try and hit that endpoint again. And we see we've got now a different error code. We've hit the info endpoint, but now we're getting a not found for path mapping. Okay, and we go look on the platform. We look at the transaction logs. And that's exactly what we want, right? Path not defined. So basically, we try to call an endpoint called /info, which according to the firewall doesn't exist. I can show you that behavior. I'm going to call another point that we know doesn't exist. Right, we haven't seen that before, and that endpoint doesn't exist either, and we're getting exactly that same error code. So, what we've been able to do there. Firstly, we had a slightly more subtle approach to fixing that problem. We removed the data record. We stopped excessive data exposure, but we show that we can also equally effectively, drop the entire endpoint. So that's really showing that joint value proposition of being able to not only do that token validation, right? We can check a number of things. We can check expiry of the token, the format of the token, the claims, the individual claims. We can check for a missing token. We can check for expired token. And then also we just as a bonus there, we showed that we can add in 2 additional data remediations based around data, where we could avoid excessive information exposure, and where we could, in fact, simply remove that broken function from the API. Now, the real advantage here is, you can do a lot of that in code. Certainly the backend that we're using can do all of that. But the advantage here, we can do it at a single point of enforcement, right? There's a single policy enforcement point, which you can deploy globally in front of all your API backends, right? And with literally a click of a button on a platform, you can reconfigure the security behavior. You also have the advantage of the segregation of duties, where the people developing your API backend, your developers don't have to concern themselves with your security requirements. They don't have to understand how does Approov work and how does Approov token validation work, but they don't even see that. Right? That's been done for them, and it's been done in a centrally governed place. So there's no need for them to get involved. And then obviously the idea that you're doing it at a central point means you have governance, you have inspection, you can track all those 42 crunch logs back to a central point, to a SIM. You can detect when people are attempting to hit your backends but not providing the tokens is obviously signs of some form of abuse. So hopefully that demonstration was pretty useful in showing how, firstly, how easy it is to attack a mobile application, and then simply how easy it is to protect that with something like Approov, and then what 42 Crunch can do to come and add that extra layer of protection via the micro firewall. Let's take a quick poll question here if we can, if we've got a second for this, if folk would like to have a go at answering that. So having had a look at what we've got and the topics that we've covered, what do you think is going to be the single most beneficial protection that you can have on your APIs?
So you should be able to see those now.
Can do. Yep. So most people have taken an interest in certificate pinning, but also that API micro firewalls. It's good to see the interest in that. This is a really good use case, and particularly being able to suppress at very quickly at runtime, being able to just remove things and harden up your APIs if you detect vulnerability. To answer the question that I'm seeing coming up about the three things we had, I think you're probably referring to the traffic reverse proxy that's just doing SSL termination in that demo environment. So I think that's that. So just to wrap up very quickly, I mean, we've got the benefits of this. We can do protections at scale. We can central govern the security protections. We can separate the development team from the security team. We can reduce human error. Right? We don't have to rely on developers doing the validation in code. And as shown, we can do that in a hotfix environment. We can do it almost instantaneously. Learning more. There's some great resources. Obviously, my API security newsletter. We take a lot of effort to get useful information in there for you. We've also got Corey Ball has published the Hacking APIs book, which I think is going to become the industry reference. And then there's also a great GitHub repo on everything awesome in API security.
It's great, Colin. Thanks very much. And I think just a shout out to some upcoming events. You know, we have our next webinar in the series. It's the final of a three-part series with Philippe Tarek at the end of the month on the OWASP API Security Top 10. So please, if you haven't already seen the first two episodes, you can see them now on demand on the 42Crunch website. Colin will also be speaking at the API conference next month in Den Haag, Netherlands. It's an industry gathering, so it's one of the first in-person events. And I think finally, I just say thanks to both Colin and especially to David for joining us today on the webinar. And we look forward to seeing you all online again very soon. Thank you.
Thanks very much.
Thank you.